Okay, so today I'm going to briefly go over why eVTOL is not the future of urban air mobility, and conventional autonomous helicopters with my innovation are going to be the future of urban air mobility. Now, the first reason eVTOL is not going to be the future of urban air mobility is that there is zero technical advantage of using that unconventional architecture, meaning that there are multiple props rather than just one main rotor. And that boils down to the physics of rotary flight, the physics of creating lift. The way you create lift is you either accelerate a small mass of air at a high velocity, a rocket engine, or you accelerate a large mass of air at a low velocity, a helicopter rotor. So ideally you want a low chord thickness, high chord length, high aspect ratio, a thin, flexible helicopter blade to create very efficient lift. That's what you do. You want as many as possible. You want, it looks like an Mi-26, right, the largest helicopter in the world. You don't use a fan, you don't use a propeller, you use a rotary wing. And so lift is mass times velocity, and the relationship between lift and power required, or essentially energy required, is a function of the velocity of the air molecules being moved. The way to create lift is by moving air molecules, and if you move air molecules at a higher rate, more power will be required relative to the amount of thrust produced. And so you want to reverse that relationship. Now, so that's the first thing. And so all these eVTOLs are going to have higher rotor downwash, thus they're going to consume a lot more power. They're also going to have higher disk loading. In addition, they have less built-in redundancy because if one prop fails, the aircraft becomes very unstable. And thirdly, from what I gather, they're planning on using very low energy dense sources of propulsion, which I wouldn't understand because these kinds of aircraft need more power to begin with. So why would you want to use a lower energy dense source of propulsion, such as lithium chemistry, which is used for cameras, but cameras don't require immense amounts of power. So the second reason is that you still have the same infrastructure and noise problems. They argue, well, the noise is different. The noise is a constant whooshing sound rather than this oscillating chop-chop sound, and that's true. The rotor blade sound frequency oscillates off and on, whereas a prop rotor would be more of a continuous low-pitch drone, but it's still nonetheless very bothersome. I mean, noise is noise. It's all about decibels, and these VTOLs are going to have about the same decibel output because you can't cheat physics. If you're going to move a mass of air, you're going to have to make decibels. If you're moving a mass of air at a higher velocity, you're going to create higher decibels. So it'll be louder than a helicopter, just be less oscillating. It won't oscillate, so it'll be in some sense less noticeable. But noise is noise, and jet engines are a continuous, relatively low pitch noise actually from a distance. A turbo fan is relatively low pitch, and it's very bothersome to people. So the noise problem is definitely not solved. And the second major problem is that you still have the infrastructure constraints. You still have to build infrastructure, and that getting that infrastructure approved is going to be very difficult, just as getting rotorcraft infrastructure approved because of the noise. No one really wants, and the safety as well. I mean, the fact is, any form of vertical flight is relatively dangerous compared to fixed-wing aircraft. And civilian rotorcraft in the air medical industry, and the touring industry have a pretty poor safety record. That's just a fact that you can't get around. And there is very little reason to think that automation is going to solve that. Because if you look at the record of autopilot in the automotive industry, Tesla Autopilot, it's not so great. So self-driving cars are incredibly difficult to design because getting a computer to essentially predict all of these nearly indefinite scenarios is virtually impossible. Now you can say, well, flight is easier and simpler. And yes, that is true. But I don't think autonomy is going to make it any safer. It might reduce cost because you can save $80,000 per year. That's a lot of money. But aside from reducing cost, it's not going to actually make anything safer. So yeah, infrastructure is the main constraint, and it's the main constraint to the main barrier that prevents rotary flight from being accessible to more people, especially people of lower means. Now in Brazil, rotorcraft are widely used for transporting very rich people because, well, A, they have the infrastructure. They built these rooftop heliports. It was demanded for by the elite in Brazil because it's a very violent society. You have it's multiracial. You have the poor blacks and Hispanics that are very commit all of the crime, and then you have these rich European people who live there and kind of rule over these hordes of poor people, and so it's very violent, and therefore if you go into the streets of Brazil, you'll get killed, and so you have to fly. It's literally that's why they do it, and the time as well. But it's not just the time; it's mostly the crime. So, but yeah, you have the infrastructure in place, and so therefore. You can have a vibrant urban air mobility economy. But they use conventional rotorcraft. They use A109, Augusta A109. It's elegant, it's good-looking aircraft, it's fast, it sounds cool, it's reliable, it's been around for 40 years. So I just don't really see why you'd go with anything but a conventional rotorcraft. Now, I've made an innovation that could potentially enhance it, but again, you're still going to have to have infrastructure. But that's where I argue my innovation solves this problem, because with my innovation you can hover the aircraft, say 100 feet over your destination, provided it's private property. I mean, you really couldn't hover over public property and winch someone out. But if it's over your own property, what you're able to do is you're able to drop off people without a heliport, because you can hover, drop them off in the capsule. The capsule is stabilized and controlled directionally via electronic ducted fans. And you don't really need much thrust to keep it stable. You can have enough thrust to keep it stable in 40 miles per hour wind with these small little electronic thrusters. And then you have a redundant polyethylene, high density, high molecular weight polyethylene cable, which provides carries the capsule, and then it's winched up and down into the aircraft. So it's kind of a modular aircraft. I'm not the only one to have thought about it. There's a guy in Georgia named Robert Talmadge Jr., who actually came up with this idea and patented it. He's got a small aerospace research company in Georgia. And aside from him, I don't really know of anybody else who's thought of it, but it's a great idea because, again, a helicopter rotor is 50 feet, so you need a big heliport to land. I mean, it's 40 feet for realistic. I mean, 37 feet, say, or actually 36 feet for your typical 3.5 ton or 2.5 ton helicopter. But if you're in a 5-ton class like an AS365, it's 40 feet. But you need some margin, right? You can't land 3 feet next to a tree trunk, and so you're going to want, say, 10 feet on each side, and then you have to have a fence to keep the kids out, and you're going to make lots of dust. And if it's a desert environment, you're going to have brownout, which causes sand ingestion in your turbo shaft, and that necessitates use of air filters, but air filters reduce the airflow of the engine, reducing the power output, and you need the most power when you're landing and taking off, or not, well, actually, yeah, you need the most power when you're out of ground with that cover, or at very high speed. The minimum power requirements when you're at like 40 knots, 40, 60 knots, I think highest power requirements either out of ground effect hover and VNE. But the point is that you want to be able to drop off your passengers, or maybe even taking cargo. You're carrying stuff, but you don't want the infrastructure. Many people say, well, helicopters can already land anywhere, can't they? Why do you need this system? Well, they can, but again, they're big, and you can't really land a helicopter in a typical residential street. It's very dangerous. You need appropriate landing sites. You need a level landing site. You need a landing site that's not muddy, so your helicopter doesn't sink when you take off. You can have dynamic rollover. You need an environment that's free of obstacles. So really, you can't land anywhere. And if you do, you're going to have a higher rate of accidents. I mean, the fact is, a large number of rotorcraft accidents happen during takeoff and landing, especially in dangerous environments. That's why the EMS helicopter industry has such a high accident rate, because they land in parking lots. I mean, you really don't want to land in a parking lot. You safely hover above. You put in 4-axis autopilot, AS365 Dolphin, MH65. Coast Guard helicopters have this autopilot system. They press a button and it'll hover on its own. You just hover and you drop off the capsule and do your job. That's a much better solution than landing and putting yourself at risk. The helicopter wants to be in the air. It doesn't really want to be landing in these dangerous terrains and dangerous settings. With light poles and trees, and there's a video of a EMS helicopter in British Columbia that's landing on this small road, and it chops the tree or the power lines, right? So it's really unadvisable or inadvisable, I should say, to land these larger rotorcraft, especially in medium to large rotorcraft in these unsuitable terrains, unsuitable environments. And then, of course, you exacerbate that when you're in urban cities, right? You're in urban areas. You're dealing with high-rise buildings and mid-rise buildings. I mean, you just can't land anywhere. You can't land on the rooftop of your typical building. So how do you really use this helicopter? Yeah, it can land anywhere, but that's in theory. In practice, it can't. So you want to have this small capsule that you can drop off, and then you can even disconnect the capsule and pick up a new capsule, switch capsules. You can have an EMS capsule. You can have a capsule tailored for charter. You can have a capsule tailored for cargo, utility. You can do all sorts of stuff with it. And I think that would solve your urban air mobility problem. And if the helicopter's further up, it's away from people. Sound dissipates rather rapidly with distance. I think it's there's a calculator on the internet that you can use to calculate the dissipation of sound sound waves over distance, and it dissipates rapidly. So, but 50 to 100 feet would be the ideal height. The other major advantage is you can drop people off on boats, because boats, if you want a yacht with a helipad, you're gonna need like a super yacht. Typical helipad, something like 40 feet, I think. So, you really can't put a heliport even on an 87-foot Protector class cutter, which is a U.S. Coast Guard boats that patrol out here in Bodega Bay. Well, actually, they're based in San Francisco partially, but you wouldn't be able to put a helipad for, say, the A365 Dolphin on that thing. So the only way you can drop guys on the boat is by rappelling. But the problem with rappelling is that it's rather dangerous. You're being blown around by the wind. You can get hurt. And you really can't drop off VIPs that way, right? So you can't get blown up, get your hair all blown away when you're going to a business meeting. So you need a more safe method of dropping people off without landing the primary aircraft. Again, we do that through rappelling, but integrating a capsule with directional control and crash resistance, right? Because the capsule would be just as crash resistant as the aircraft, and the likelihood of the capsule crashing is no more likely than the likelihood of the main aircraft crashing, because they're interconnected and cables have a minimum break strength. I mean, polyethylene, high-density polyethylene was designed to more ships, more like container ships. So it's like 10 times stronger than steel. It's very abrasion resistant. It's very durable. So the capsule cables are not going to be susceptible to damage or failure. And if you were to have an accident, again, the capsule is just as crash resistant. Now you can say, well, the capsule can't auto-rotate. Well, the problem with that auto-rotation argument is that helicopters are going to be doing the work that you buy a helicopter for, which is literally hovering, right, and dropping off people on an offshore wind turbine, or offshore oil rig, is when you can't auto-rotate if you're at zero airspeed, right? So you're out of your, in the dead man's curve, right, you're out of the auto-rotation area if you're at low airspeed, and so you need two engines, or you need a redundant propulsion system. That's just a fact. And that's an argument for the VTOL guys that say, well, auto-rotation really by itself is kind of not that useful for most of us. I mean, let's say you're flying over a big city. You're like, okay, well, you auto-rotate. It's not very useful. You're going to come crashing down into a high-rise building. So I wouldn't really moan. I mean, some people critique my idea and said, oh, well, you'd be in his OGE hover all the time, out of ground effect hover at zero airspeed, which is terrible because you can auto-rotate. But I debunked that argument by saying, well, the whole point of buying a helicopter is to be able to hover and do these kinds of missions, and so who cares? What we want to do is make the helicopter more versatile by being able to drop off passengers or cargo at any given destination, regardless of the terrain, regardless of the area given, and that's only provided by my innovation and also Robert Talamage in Georgia. I don't take credit for being the only one to have thought about it. As far as I know, I'm the second one to have thought about it. So it's a very niche and specific innovation, obviously. But anyway, I'm getting close to my 15 minutes. And so that's about all I have to say. I encourage people to read my description on the internet. And I would highly recommend this to be used for emergency air medical missions. Because, well, A, you wouldn't need a rooftop heliport. And B, you would be able to pick up people in really cluttered areas, I should say. Very cluttered parking lots full of scrap cars, maybe, would be a great application. Again, anywhere where it's confined areas, trees, right? Big trees with trunks. I mean, you don't want to hit rotor blades on a tree trunk. So anywhere it's confined, you want to use this. Or the terrain's really muddy, right? So I can go on and on and on. It's pretty basic. People should understand.